Hey, welcome back. Today we're looking at exponential functions. This is 5.3. Just as a review, we're going to use it later, and you guys are going to use laws of exponents. For those of you who are going to calculus extensively, you're going to be expected to know these rules, so it's a good time to review since we're doing exponential functions. So the first rule says if we have the same base, in this case we have a, and we're multiplying, then we can add the exponent. So a to the s times a to the t is the same thing as a to the s plus t. So this would be the product rule. The second one is if we raise a power to a power, so we have a to the s raised to the t. What we're allowed to do is say that's the same thing as s times t. So this would be the power rule. And then the next one, we have a to the b in parentheses, a times b in parentheses, excuse me, to the s. And what this is like we're distributing the s to each of the parts inside of the parentheses. So a to the b to the s is equal to a to the s times b to the s. Okay, so this is just, I don't know if I had his name. It's just saying that if we have things in parentheses, that the exponent applies to the whole parentheses, I should say everything inside the parentheses. Okay, and then 1 to the s is equal to 1, so that's kind of self-explanatory. No matter how many times we multiply 1 by itself, it's still going to be 1. The next one, a to the 0 is 1. Those of you who had me for Alge-Bruh, we kind of talked about this, but I'll go ahead and show it to you, what it looks like. So I'm going to make a table here. And this kind of gets into the next one too. So let's say we start with something from there. Let's say we have 8. So 8 is 2 to the third, which is 2 times 2 times 2. And that's going to be 8. So this would be the what should I say, simplified version. And this is 2 to the x power. And the middle part is where we're just showing our work, just so we can conceptually understand what's happening here. Okay, and then we can have 2 squared, which is 2 times 2. Simplified version is 4. And then 2 to the 1 is just 1, 2. Simplified version is 2. So now we're getting into the weird part, like, so what is 2 to the 0? So if you just kind of think about it, 2 to the 0, you would think would be 0, maybe, right? It kind of makes sense, because if we're thinking about multiplying, which is what exponential functions do, 0, then you end up with 0. But technically, the exponent is not just multiplication. So let's follow this pattern then. So if you notice here, from 8 to 4 and 4 to 2, we're not subtracting or adding to get to the next number. What we're doing here is we're dividing by 2. Right, and then we divide, then we're dividing by 2 here. So if we follow this pattern, 2 to the 0, when we divide by 2, should be 1, right? 2 divided by 2 is 1. All right, so let's make a note here for this one. Anything to the 0 power equals 1. All right, so something that we need to remember. And then let's continue this, because the next one talks about negative exponents. So 2 to the negative 1. Well, I don't know what we're going to put for work here, right? Well, actually, we could put a 1 here. And then if we follow our pattern here, if we divide by 2 again, then we get 1/2. And then if we do 2 to the negative 2, follow our pattern, divide by 2, half of a half is 1/4. So what you're going to notice here is that for 2 to the 1 and 2 to the negative 1, these are reciprocals. Same with 2 squared, which is 4, and 2 to the negative 2, which is 1/4. So any negative exponent, what that says to do is take the reciprocal. Alright, so just a quick review. We're not going to be covering it too much today in our work, but figured it was a good time to review. So we refamiliarize ourselves with this concept. Alright, so the actual work for today is pretty easy. Exponential functions can look like this or that. It's pretty much the same stuff with different letters. The book uses c times a to the x, but I see a lot of times in other work that we have y equals ab to the x. Either way, the parts are the same. So whatever thing is in front, the c or the a, these are the initial values. Right, so initial value means the f of 0. So if our exponent x is 0, then the a and the c, or the c, would be the starting amount. So on our y-axis, where we would be. Okay, then we also have the base. The base would be the a or the b. So those blue ones are the base. And another way to think about that is the multiplier. So every time we increase our x by 1 unit, that's how much we're multiplying the value by. Okay, and then lastly, the x is our exponent. And that's pretty self-explanatory, right? We know what exponents are and what they mean to do. All right, so when we're looking at exponential functions, first we're going to look at tables. It's a good place to start. So what the characteristic of an exponential function is that we multiply or divide by the same amount each increase in x. So like we saw earlier in our table here, we're dividing by 2 each time, and therefore we had an exponential function. Now if we go back over here, when we're looking at linear, which you guys did extensively in Algebra 1, we add or subtract by the same amount each time. So the first example is going to just be looking at 3 different tables, and we're going to determine, is it linear, is it exponential, or neither. So we're going to look at the differences here. So the first one, right, so 5 to 2 is -3, 2 to -1 is -3. Okay, so we found that each time we're subtracting 3. And because we're subtracting by the same amount each time, we know that this one is going to be a linear function. Okay, let's do the same thing here. 32 to 16, well, that would be subtract 16, but then 16 minus 16 is not 8. So we know that we're not subtracting the same amount each time. We can get to 16 by dividing by 2. And then 16 divided by 2 is 8. All right, so 8 divided by 2 is 4. And then 4 divided by 2 is 2. So in this case, because we're dividing by the same amount each time, then this is going to be an exponential. And the last one is a little bit weird because it's neither, because each time we're adding by a different amount. So +2, +3, +4, +5. So this one is going to be neither linear nor exponential. And we know that because we're not adding or subtracting by the same amount each time, we're not multiplying or dividing by the same amount each time. Okay, the next part is we're just going to do calculations. So 2 to the 1.4. So what we can do here is we can go to our calculator. I guess it's not up. Calculator. later. So we're going to do 2. This button raises it to the power. And we just do 1.4. Hit equals, and let's do round this to the nearest thousand, so 2.639. I'm going to use the squiggly line because it's a round. 2.639. Okay, next is 3 to the square root 2. So we're going to do 3. Hit that exponential button again, our exponent button. And we're going to do, where's my square root? Square root of 2. Hit equals, and we get 4.72, and we'll round the 8 up to 9. 4.729. Okay, e to the 4th. We're just making sure we know where all our buttons are. So we have our e to the power of 4. And then that's going to be 54.598. 54.598. And last one, pi to the pi, because it looks interesting. So let's do pi to the pi, hit equals, and we get 36.462. All right, and I believe that is it for today. So the work should be pretty easy. You're going to be doing the linear, exponential, or neither stuff. Then you're going to be just doing some calculator work. Make sure you round to the correct decimal place. Yeah, so hopefully it won't be too hard. If you do have questions, please bring them next class, and we can cover them then. All right, good job.